One of the major tasks that takes up a good chunk of a DBA's time is working out and maintaining a database design that meets a company's needs. They need to know what kind of data exists or will exist, the usage patterns, naming conventions, identifying keys, relationship constraints. For many database systems, this is a time-consuming manual task, something of a black box that can only be accomplished by a DBA. But Vertica includes a tool, the Database Designer, that creates and deploys an optimized data storage design without requiring specialized database knowledge. You don't have to be a DBA to run it. Users with little or no knowledge of Vertica's architecture can take full advantage of the system, saving time and effort. The Database Designer, or DBD, takes advantage of your existing knowledge of your data to build a data model that fits your system needs. It leverages your knowledge of typical system queries and your existing database schema and usage patterns to create a data model. That model will be optimized for your particular needs: improved query performance, faster data loading, or reduced storage footprint. By combining these two features, your optimized database design will increase query performance, reduce your hardware costs, and reduce your database maintenance costs. Let's do a quick review of Vertica's underlying data storage architecture, projections. If you need more information, please check out the Vertica projections video on this channel. Vertica maintains tables as a logical representation of your data. This way, you can still access your data using standard SQL without having to know anything about the underlying architecture. However, this isn't where data is stored. The data is physically stored on disk in projections, a structure that contains some subset of the columns from your table. When you first load your data, Vertica creates a super projection, or a projection that contains every column in your table in order. While you will get a faster query response from this projection than from a table, it is unoptimized. That is, it doesn't take into account your typical queries or system requirements. After running the DBD, your unoptimized super projection will be replaced with one or more optimized super projections, as well as some number of projections that have been built to optimize performance for specific queries. For example, if you have a query that never references column A, then the projection customer P2 will be selected to run that query because it will be faster and use fewer resources. If you want to learn more about how specific projections are chosen, check out the query execution video on this channel. This is a high-level overview of how the DBD optimizes your data. It starts with you. You need to provide information about your optimization objectives, access to representative data, your most representative queries, current database considerations, etc. Then the DBD goes to work. It iteratively considers the queries you have provided, generates possible projection designs, does a cost-benefit analysis of each prospective query, then chooses the projection or projections that best meet your needs. The next step is to figure out how to efficiently store that information on disk. For each column, the DBD tests different encoding methods to determine which creates the most efficient storage footprint. Once the storage optimization phase is complete, the DBD outputs two scripts. The design script contains the create statement for each projection to be built, and the deployment script is a SQL script that actually creates the projections in your database. Here's an example projection DDL created by the DBD. It shows the columns that will be used in the projection, as well as the encoding method for each column, the base table from which the column values will be selected, the sorting information for the projection, the segmentation key or keys for the projection, and the case safety information for the projection. We're going to walk through running the Database Designer using a wizard in the Management Console, Vertica's browser-based performance monitoring and management tool. When the wizard is launched, you'll first be prompted to name your design. Pick a name that will allow you to easily determine exactly which design output you are selecting. Your next step is to determine your design mode, comprehensive or incremental. The comprehensive design is typically done after your first data load and compares all of your representative queries to your whole database to build an initial set of projection designs. An incremental design is typically done only after your database has been in use for some time. You may find that you have a new set of common queries, or that the amount or type of information stored has changed. In this case, the initial design is no longer adequate. Running Database Designer in incremental mode allows you to focus your redesign only on those new queries without having to rebuild your entire database. Now that you know what type of design you're building, you need to tell the DBD why you're building it, what your optimization goals are. There are two goals at the extreme edge of database design: minimizing your storage footprint on disk and maximizing your query performance. If your goal is to create the smallest database possible, thereby decreasing the time it takes to insert data, set your goal to optimize for load. This will minimize the number of projections created, so there are fewer places into which data must be loaded. If your goal is to have your queries run as quickly as possible, set your goal to optimize for performance. This will create more projections, thereby affecting the data load time, but the projections will be closely tuned to the queries you will run. In many environments, both loading speed and query performance are important, so you can split the difference. Choose the balanced optimization goal. In order to optimize your database design, the DBD will need a set of representative data to compare against your queries. We're looking at the schema definitions in the sample database vmartdb. This sample database is included in your Vertica installation. There are 3 schemas in this database that contain company data. From the wizard, select all of the schemas referenced in your queries. Whenever possible, we recommend that you use your whole database. The Vertica database also includes 3 schemas that control and monitor the Vertica database itself. These last 3 schemas will never be available for query optimization. Next, there are 3 design configuration options you need to consider. The first of these is determining the case safety setting of your design. For segmented projections, the case safety setting determines how many copies of each projection segment will be created and on which node the copies will be stored on. Consider this 5-node cluster with a case safety setting of 1. Vertica creates a copy of each segment called a buddy projection. Each of these buddies is stored on the neighboring node in the cluster. This arrangement allows for node failure. If one of the nodes temporarily goes down, your database will still remain functional until it is brought back up, because the data in each segment is still available from another node. The second available configuration option is the ability to propose unsegmented projections. If you have projections that contain a large amount of data, Vertica will segment the data in those projections and evenly distribute it across the cluster. But if your projection only has a small amount of data, segmenting it may lead to a performance hit because so little data is returned for the resources consumed on each node. The DBD can compare the relative amounts of data for each projection. If the projection contains a much smaller amount of data than is typical for your dataset, DBD will design it as a replicated or unsegmented projection. Instead of spreading the data across the nodes, a full copy is maintained on each node. The third configuration option takes into account any correlated columns in your queries. Take a look at this query and the table it was designed for. There are only 3 columns referenced from the table, so any projection built for this query will only contain those 3 columns: state, city, and registered. If correlations between columns are not taken into account, then the database designer will most likely create a projection with those 3 columns in order of their increasing cardinality: city, then registered, then state. But this might not give the best query performance. If you choose to design with correlated columns in mind, then the order of grouped columns and the query predicates are taken into account. The DBD will most likely build a different projection column order: registered, then state, then city. In order to optimize your design, you will need a set of representative queries to design against. You can use your query history as your representative sample by using the query repository. From here, you can select the recently run queries you want to base your design on. If your query repository is not representative of your typical queries, you can select an input file containing those queries you want to use. Vertica ships with the files to build a sample database, vmart. In the examples directory, there are a number of sample query files you can use to build your database design. Go ahead and explore the designs you can get from each one. Finally, you can choose what the DBD will do once it has a design in hand. If you want to ensure that your table statistics are up to date before building the design, select the Analyze Statistics checkbox. Once a proposed design has been set, DBD can automatically build the design file, which includes all of the proposed projections. This allows a DBA to review the design proposal and manually make whatever tweaks are necessary before deploying it. And finally, if you're sure that the DBD is building the most optimal design, you can ask the DBD to automatically deploy the design once it has been built. If you select the Auto Deploy checkbox, you must also select the Auto Build checkbox. When the DBD completes, it creates an output file with all of the proposed projection definitions. You can edit this file to tweak those definitions, or accept it as is and deploy the design to build them. Thanks for watching. There's more to learn about how Vertica designs projections for different objectives. In the Vertica Essentials instructor-led course, you'll learn more about projection definitions, and you'll use the Database Designer to build and deploy a sample query design. In the Vertica Query Performance Tuning class, you'll use the DBD to improve the default designs from proposed output and how to manually build more advanced projection designs. Look in the notes below for a link to the course registration system. And finally, you can access the full Vertica documentation set from the My Vertica portal. A direct link to the section on creating a database design is also in the notes below.